wanted to point out this comment. Andrew Cumming. There is no scientific support. What an assertion. And after correcting Andrew so many times, Ben, praise, Sam, there's no scientific evidence for young Earth creation. The helium and zircon crystals, the C14 in diamonds and coal, the arguments that we put forth from molecular clocks, none of it is good evidence for young Earth creation, apparently. Ben, if someone were skeptical, as we start to wind things down, if someone were skeptical, you're in an elevator, but they're actually open-minded. Here's the thing, okay? A good question to ask, I think, skeptics is, if Christianity were true, would you be a Christian? You'd be surprised, or maybe you're not surprised, but there are many atheists out there that would and have said no. Well, that means no amount of evidence is going to convince them. People like Aaron Ra, Matt Dillahunty, T-Jump, these militant atheists, they've said that even if Jesus or God himself came down, presented himself to them, they still wouldn't believe, because they don't like the God of the Bible. They don't like the morals. They don't like what God has to say. Anyways, so I'm talking about an objective thinker, someone who's willing to look at the evidence. If they were to say in an elevator, Ben, and you only had 30 seconds to a minute, they were to say, there's no scientific evidence for young Earth creation, but I'm willing to listen. They were willing to listen. What piece of evidence, one or two, would you look to? Which do you feel are just really powerful and persuasive?
If I only had 30 seconds, wow.
Let's give you a couple minutes. It's a longer elevator trip.
If I only had that amount of time, I would probably use the argument about salt concentration in the oceans, because that's really easy to explain. The rate at which salt accumulates in the oceans because of runoff from the continents, salt dissolves into rivers and runs off into the oceans. And so but when water evaporates from the surface of the ocean, the salt doesn't evaporate. So it leaves the salt in the ocean and the water cycle continues. So that means salt is continuing to accumulate in the oceans. And there's a rate at which that occurs, and we've measured it. And if the oceans are billions of years old, the ocean should be way past the saturation point. There should be as much salt in the oceans as there can be, and there's not. And so that is evidence, very good evidence, that the oceans are young. Another one, if I had time, would be the cold spots they found in the Earth's mantle near the core. These are measurements that are made where they infer a temperature based on the motion of the material down there. And they found these cold spots that are something like, I think, 500 to 1,000 degrees Celsius colder than the surrounding mantle. And they're way down there. They're near the core. And as you know, things, if they're surrounded by a really hot thing, they will heat up. The heat will equilibrate over time. That's how your stove works. The stove top heats up and the heat is transferred to the pot or whatever you're cooking. Okay. And so over time, the heat would equilibrate into those areas. And what the cold areas show is that there's not been enough time for that heat to equilibrate there. So there are these cold spots down in the mantle that have to be young. And the creationist model of the flood, the catastrophic plate tectonics model, gives a mechanism, if I'm running out of time here, gives the mechanism for why there would be those cold spots down there, and recently.
Yeah, those are great. So your first one, basically, we know the rate as to which salt accumulates in the oceans, meaning if the oceans were as old as old Earth proponents would say, then the oceans should be oversaturated at this point, basically, is what you said. Yeah.
Yeah. In chemistry, there's a thing called a saturation point, where it's the maximum amount of a solute that can be dissolved in a solution. and the oceans aren't there yet.
What if a critic were to say, well, that rate is not constant?
Well, then why are you angry at us for saying that the rate of nuclear decay is not constant?
Because double standard.
Right. But the point is that if you want any kind of extrapolation from current data into the past, you have to make assumptions. Okay. And so if your assumptions are incorrect, then your conclusion's incorrect, obviously. But that's a problem that everybody has to deal with. It's not just us. And yet people still make these arguments. So it's an argument. It's not meant to be a logical proof. There aren't any proofs in science.
Right. We're supposed to disprove things. And so, okay, that's a good point. Your second one, that's one of my favorites as well. These massive slabs of cool rock that we find deep within the earth that must have been subducted there just thousands of years ago, or else, as you said, they would have either assimilated to the surrounding rock or even melted if they were taken down there millions of years ago through snail paste movement. It would be like my coffee. It's cold now. It's been sitting here for 3 hours, right? We've been doing a marathon here. And so it's cold. But if it was still hot and steam was coming out, we probably haven't been doing this for 3 hours unless my wife brought me down a fresh cup of coffee. Or if you put an ice cube into a hot coffee. And I said, that coffee's been sitting there, and it started off hot. It's been sitting there for 5 hours, but the ice cube was, not melted. Well, it probably hasn't been there for that long. So I think that's a great point, Ben.
A little story about that. I mentioned this to one of my professors at Biola who's has a science background. And I know that he was thinking about it because he came back on the class message board and said, well, I looked into this and this is actually they think it might be actually due to the motion of what's going on down there, not the temperature. Mm-hmm. And I didn't have time to respond to that, but I'm like, I know that he was looking at stuff that made him think a little bit, so that's good. But the point is that he had it a little bit backwards. Is we infer the temperature from the measurements that indicate the motion. Okay, so the temperature is an inference, but it's a solid inference that's made in the secular literature. So wouldn't motion make it warmer? Well, so things have motion if they have a temperature. Okay, so they're comparing it to the motion in the surrounding mantle. Okay,
and to people listening who might be new to this, these cold slabs that we find, that is, I think, really good evidence for rapid plate movement during the flood, because a lot of critics will say, oh, that's post hoc ad hoc, the meters per second movements of the plates during the flood year to get the continents to where they are today. But hey,
ergo prompter hoc.
Yeah. But at the same time, we find these cold slabs, which we say that must have been due to rapid runaway subduction, which one could say is a confirmed prediction of the model. Or else, they should have been melted or at least assimilated to the surrounding material. So those are two really good points, Ben. I think you would have converted or at least got that skeptic to think in the elevator, brother. Sam, where would you point them?
So I'm a diehard transcendental argument guy. So if we're going to talk about science, I would point out, like I have with Andrew, that science has preconditions. And the naturalist, the atheist, their worldview cannot satisfy those preconditions. And then I would make a positive argument that it is the Christian worldview alone that satisfies those preconditions for science, intelligibility, and therefore Christianity is objectively proven. And the critic, like Andrew, is living in God's world, but pretending that there is no God. And I've made these arguments with him, with Erica, with many others. They can't address it. There have been atheist philosophers that have made these arguments. That's the argument I mention regularly that brought Anthony Flew to deism, one of them anyway. So there's powerful arguments. But that would be the argument that I would make. But I do agree with Ben, and that's a fantastic argument. There's also hot blobs, so it's not just cold slabs; it's hot blobs, and that just compounds the problem. Because I didn't have hot coffee; I had cold water with ice cubes in it, and they are melted now.
Yeah.
How do you explain that? And of course, they've got their little just so stories. They're gonna pretend that they got it all figured out, like your professor, Ben. But okay,
yeah, because the hot blobs are displaced by the cold blobs, right? So the hot blobs get pushed up in the mantle as the cold blobs go down. Another quick point to make on that is that we touched on it sort of, but to be clear, if the rate of plate subduction that we observe now resulted in those cold spots being down there, the rate that we observe now is so slow that even way before those slabs would have gotten to that distance down in the mantle, they would have melted already and essentially become part of the mantle. So the rate of subduction is an issue there as well, because I think you did mention that, Donny, but just to be clear, is like, as it's going down, if it's going down that slowly, it's equilibrating in temperature as it moves. So it's also evidence that it had to be really rapid subduction.
Yeah, like slow, ever so slowly putting a candle into molten wax. If you do it really slow, it's going to melt.
Which means this is another challenge I want to issue to theistic evolutionists like Redeem Zoomer. Let's see you respond in detail to just a couple points here. We've done entire shows where we go over in detail the amazing science of young earth creation. And let's see one of these theistic evolutionists actually put in the work, put out a video responding, and we promise you we'll respond to the response. Because, see, here's the thing. Everybody's going to have rescue devices. Where we're dealing with worldviews here, and both sides might have to have rescue devices now and again. But the question is it a good rescue device? Is it a convincing rescue device? And so many times the evolutionist puts forth rescue devices that are nothing but fanciful storytelling, like the way they attempt to explain the Y chromosome dissimilarity argument, or the way that they try and explain the C14 in diamonds through contamination and other means. They don't even really have a good one for the helium and zircon crystals. The cold slabs is another one. And so to what you said, Sam, great points. I'd recommend, so Jason Lau, he just put out a really good presentation on that on the Answers in Genesis YouTube channel. I listened to the whole thing, really good. But he also goes into some of the objections that could be made to what you're saying, Sam, and then he refutes those. And it got me thinking as well. So that's really good. Okay. Andrew Cummings says, the helium in zircons is easy to explain. So easy, he asserted it. You just ignore the answer. Dr. Russell Humphreys, he did a written exchange, 4 or 5 of them, with a scientist from Reasons to Believe who attempted to refute Russell Humphreys' work on that. And Russell Humphreys did an excellent job responding to all those criticisms. So I would be surprised, gentlemen, if there's a criticism or so-called objection that have been put forth by the critics that Russell Humphreys hasn't already debunked.
They've even published one in one of the Young Earth journals. They published a criticism of Humphreys' work, and then Humphreys responded in the journal.
Well, I didn't know that. Okay. Even more then. That's great.
I can't remember the guy's name, but I think his argument was something along the lines of, it was a very technical argument around I think the size of the grains that they measured or something. And Humphreys' response was basically, okay, even assuming, he basically argued, no, this is the way you do this. It's a standard methodology. But then he basically said, even if you take all the assumptions that you gave in your criticism and assume they're all correct, that still gives about maximum 1 million years for this.
Wow.
Which
incredible.
is not close to enough for the old Earth view.
It's incredible.
When you had Dr. Aaron Shoulders on, molecular biologist, talking about the biological decay rates within the dinosaur soft tissue, the critics will suggest that these things have been refuted. Like Andrew will say, "Oh, we've dealt with those," but they're dealing with them are just assertions that can't be defended, and that's what Dr. Shoulders pointed out. There have been assertions about what might preserve this soft tissue that we find in dinosaur bones, but nothing that can be actually defended. So let's make that clear, that there's a distinction between an assertion that something's been refuted and whether or not something has actually been
right. Let's see these critics publish in the Answers Research Journal. They do it, as Ben said. Dr. Stefan Frello published several responses. He's an evolutionist. He's not even a theist, as far as I know. And they published his critiques of Dr. Nathaniel Jeanson and his replacing Darwin model. And Dr. Jeanson responded, and I think he responded adequately. You can leave that up to the reader to read all the exchanges and come to their own conclusion. And so the critics need to put in the work, and they can publish rather than making assertions. And I've done whole presentations on this, so I'm not going to give another one here, but I just wanted to refer people here. So here's the paper I'd highly recommend reading. We can see if Redeem Zoomer can refute it. Helium diffusion rates support accelerated nuclear decay. So we know the rates of helium diffusion, and these zircon crystals are supposedly billions of years old. And uranium to lead gives off helium. Helium is produced. It can move through rocks. Since rocks are porous, the gas escapes through the rocks. And helium being a slippery molecule, we shouldn't find the kind of helium that we have in these zircon crystals, because billions of years, you'd have plenty of time for the helium to basically leak out and escape into the atmosphere. So anyways, Dr. Russell Humphreys did all this work, and notice what he said in this.
Not just him, it was a whole group of
the whole rate team. Yeah. Baumgartner, Austin. And so here,
though the rocks, though.
And this goes to
doesn't count.
Yeah.
Yeah, they'll immediately start attacking the sources a lot of times, especially people who don't know what they're talking about. They say, well, that's a creationist source, therefore it's wrong. This is a clear ad hominem argument. Yeah. And I would just like to emphasize before you continue that I've now published in the Young Earth literature, and I can tell you my paper went through peer review. Okay. Right. I got it back several times, okay, with suggestions and criticisms. And in my case, it was even from a guy who actually disagreed with me. And in one case, he actually rewrote an entire, like half of one of my paragraphs. And I looked at it and was like, oh, that's way better. Thanks.
Oh, wow.
You know, CMI does a great job at peer review. And I don't doubt that that is the case at all these other Young Earth journals, like the Answers Research Journal, which is freely available online. So there's no excuse not to go read it. The Journal of Creation is the one I published in. Then there's the proceedings on this. That's this one here, the Proceedings of the International Conference on Creation. That's like the creationist version of PNAS, basically. There's one more peer-reviewed journal that I know of, and it's escaping me right now. But Young Earth creationists do legitimate, real peer review, and we have disagreements in-house, which means that there are people criticizing each other within the community, providing as iron sharpens iron. Okay, it's a real scientific community. It is not a bunch of crazy random people. These are people with PhDs from major universities, secular universities most of the time, and you know, people you can't wave this away by attacking the sources, is all that I'm saying. These are legitimate scientists with legitimate degrees, and they're doing real peer review and publishing.
Man, good for you getting your papers published, Ben. You're right. It's a rigorous process. You've done excellent work, brother. And rather than people attacking the sources, attack the arguments, attack the math, attack the data. And right here, they can look at this. This goes to a debate you had with Adam Terry. And he and others, they will ask, show me a scientific evidence that doesn't just limit the age of the earth, but actually gives roughly 6,000 years. Well, here's one. The authors here said, though the rocks contain 1.5 billion years worth of nuclear decay. Okay, so people wondering what that means. Basically, you have evidence for 1.5 billion years worth of nuclear decay from uranium to lead in the zircon crystals, but then you got way too much helium present in those rocks for those rocks to be billions of years old. So how do you account for that apparent discrepancy? You got evidence for 1 billion plus years, but then evidence for just 6,000 years. Well, a good conclusion would be, okay, you had all of that decay from uranium to lead, but you had it quickly. The decay occurred in an accelerated manner in order to retain so many helium atoms. And so anyways, his conclusion shows that the helium has only been leaking for roughly, there it is, only 6,000 years plus or minus 2,000. That's just the nature of how those things work.